Hello grade 12s, welcome to my channel. Let us have a look at this question paper and use it as our way of sliding back into the revision mode so that by the time the trials come, we are in a good shape. So we're going to look at this Northwest question paper from June 2025 and try and find some strategies and of course highlight certain issues that are of importance in paper 1. Alright, so we read instructions, guys, making sure we understand each, and of course these kinds are to be put to memory, especially that part. Many take this for granted. And of course this instruction as well, which tells us to take our answers to 2 decimal places if we ever have to round off. No more, no less. All right, so this is as clear as it is given. Right, let's get to the question 1. Sometimes I refer to question 1 as a warm-up question. This is setting the mood for the entire paper, but you will notice that most of these questions are warm-up questions because this is what we already know. Then we get some examination questions where we are then asked to do a little bit more, of course applying the same principles. So 1.1 has 1.1.1. We are solving for x, so we have x squared minus x minus 12 equal to 0. If you are a student and you don't know what to do here, just check the discriminant first. If it is a perfect square, it means we can factorize. So, but again, it's usually very easy to tell whether this needs to be factorized or not. Factors of 12 that can give us a 1 is basically minus 4 and plus 3. Strategically, so therefore x is going to be minus 3 or x is 4. Nice and easy. So we get our answers. But remember guys, we always check our answers. Do not find yourself losing marks in this section because of not checking answers. If we take a 3 and put it into the original, what do we get? So we're going to get 9 plus 3, which is 12. 12 minus 12 is 0, so 0 is equal to 0. The left-hand side equals the right-hand side. Put a 4 where x is. This gives us 16 minus 4, that's 12. 12 minus 12 is 0, so 0 is equal to 0, meaning the left-hand side equals the right-hand side. And we get an extra mark for our factorization because this is the 3-step approach. Right, next question, we have 5x squared plus 2x is equal to 9. And we are told to solve correct to 2 decimal places. This is already suggesting that this quadratic has irrational roots. So we just write it in standard format. At this point, you can choose to do this by completing the square or use the quadratic formula. But either one of the 2 techniques is one and the same thing. So they come up with the same answer. Okay, the right-hand side is divided by 2a. We need to write it down and then solve. X is equal to, so we get 2 into the square root of 2 squared minus 4 into 5 into minus 9 divided by 2 into 5. Okay, again guys, knowing how to use the quadratic formula is as good as knowing how to add sums or division and multiplication. What is important here is to make sure substitutions, guys, are correct. That is the one thing that is crucial in this calculation. Doing it wrong is punishable. So we need to make sure this is the case. So the first one is 1,16 to 2 decimal places, or x is, so please guys make sure. So this is minus 1,56 to 2 decimal places. We then close it. Now, same thing. We need to go back into the original and check if our solutions hold. Now, the right-hand side is a whole number. Since these are decimals, we will get a decimal here. So we need to round it off to the nearest whole number, right? Great. So we've got 5 into 1,16 all squared, plus 2 into 1,16. So what we have is 9,048. So to the nearest is 9. So 9 is equal to 9. So this is good. We can accept that answer. The next one is minus 1,56. So these calculators are very friendly, guys. Make sure you take advantage of these, because there's no excuse. So we get the same answer here, 9,048, which to the nearest is 9. So left hand side equals the right hand side. And of course we get a mark for substitutions. How many marks there? 4. Okay. Putting it in standard format is also mark worthy as some part of a law, theorem, or whatever you call it. Remember the 3-step approach. If you don't know what that is, well, good luck. Just check the channel for more. You will understand. Okay, easy 4 marks there. So 1.1.3. We have a parabola here, 18 minus 3x minus x squared greater than and equal to 0. So this is a quadratic inequality. Well, most likely we will win if we try and factorize this thing. Many students like to do it the old way. It's up to you, honestly. What factors of 18 can give us a 3? It's a 6 and a 3. And here we will have, now we need to think about x and x, okay? But now we want a situation where we get this as a negative. So this must be minus x plus x, right? Because 6 times minus x is going to be minus 6x plus 3x. It gives us minus 3x. This and that gives us 18. This and that gives us x squared. So this is good. Now once we factorize, we can put it on the Cartesian plane. Maybe it's too long. I don't like it like that. We don't want it too much. We just want the sketch. Since this is a grumpy face parabola, we will make it grumpy. X, Y, origin. I don't know, lately this origin refuses to look like it. Of course, guys, we're going to get minus 6 and 3. So this is how it's going to go. Right. I don't like it. Okay, it refuses to give me the shape nicely, but it's still not bad. So what do we have here? So this is going to be minus 6. This is going to be 3. This is 18. Okay, a near perfect sketch, guys, is key. Now we want the graph to be positive, and we can see it's positive in between the critical values, and it is 0 at the critical values. So how do we construct our solutions? We'll then say, well, this is included as well as that. Okay, and in between the graph is positive. So what do? We write our solution. Therefore, x must be less than or equal to 3, greater than or equal to minus 6. We can add here x is an element of all real numbers, just to make it a habit that we take care to not forget the domain. But some students may prefer to write here x is an element of minus 6 and 3. The interval notation automatically means x is an element of real numbers. Okay, yeah, that's about it. That's about it. Let me just get this message. What is it about? Okay, just a moment, guys. All right, guys, so we get our marks for this. It's usually 2 marks. And factorizations. So this was 4 marks. So the 4 marks could be the sketch, or it could be the domain, or whatever. So at the end of the day, we have 4 marks there. All right, so 1.1.4. We have 6 minus the root of x plus 4 equals x plus 4. And we isolate our radical, so this is minus the root of x plus 4 equal to x. When we transpose 6, it becomes minus 6, so we end up with minus 2. Now we perform the gymnastics in the next step. All right. So we have x plus 4 equals x minus 2. Please make sure your work, guys, is clean and easy to follow as to what are we doing in each step, okay? Do not overly combine steps. So this is going to be x plus 4 equals, this is x squared minus 4x plus 4. Now immediately that takes care of that. Then we transpose the left hand side into the right hand side and then rearrange. We get x squared minus 5x equal to 0. We take out the highest common factor and we then have x as 0 or x as 5. We then check these solutions back into the original, okay, to see if the left hand side balances the right hand side and that under the radical we don't get a negative number. So what we have here, we take 0 in there, so it becomes square root of 4, which is 2. 6 minus 2, that's 4. Put 0 there, so 4 is equal to 4. So this solution holds, okay? Next, put this one in there, we get 9. Square root of 9, that's 3. 6 minus 3 is 3. Put a 5 there, we get 9. So 3 is not equal to 9. So we strike this one. Again, we get a mark for doing that. And normally we get a mark for our factorizations and the gymnastics. Wow, 6, come on. That's not fair. It's not correct. So we can say, okay, writing that in standard format maybe, or the outcome of the squaring, and essentially isolating the radical. But I think this is crazy. It's not supposed to be like this at all. think the examiners here are just smoking ganja or something. 1.2 says solve x and y simultaneously. Easy stuff. So we've got 2y minus x equals 3. So this implies that x, we can isolate x, is going to be 2y minus 3. We make this equation 1 together with the other one as it is. 2y squared plus 3x minus 2xy equal to 0. We can make this one equation 2, then we do the substitution method. We will put 1 into 2, such that we've got y squared plus 3, where we see x, we put 2y minus 3, minus 2 into 2y minus 3 into y equal to 0. So this implies that we've got y squared plus, this becomes 6y minus 9 minus 4y squared plus 6y equal to 0. So we sort up like terms. This gives us minus 3y squared plus 12y minus 9 equal to 0. We can divide by minus 3. We get y squared minus 4y plus 3 equal to 0. We can factorize. So now this is y minus 1 minus 3. Therefore y is 1 or y is 3, which also tells us that x is going to be 2 into 1 minus 3, or x is equal to 2 into 3 minus 3. So this becomes minus 1, this becomes 3. Right. Again, we should not just celebrate the solutions, guys. We take this pair and put it back into one of the originals. The linear equation is much better. So if we put y as 1, this is 2 minus 1 is going to be 2 plus 1, which is 3. So 3 is equal to 3, so the left hand side balances in the original. So it means we followed everything properly. We do the same. We take these and substitute into that same equation. What do we see there? So this is going to be 6 minus 3, which is 3. 3 is equal to 3, so this is good. So that that pair also works out. So the technique of substitution, how many marks there? 6. So perhaps writing that modified is key. So again, it's a standard question, but remember, simultaneous equations become very useful for higher grade questions. You must always know what to do. Next, we are told that if x cubed minus y cubed is equal to x minus y into x squared plus xy plus, this is now the difference of two cubes, right? Which we should know from grade 10. We need to show that this is the case. And of course, if we inspect here, this was a 3, this is 3 squared over here. Right? So this exactly means if that was x, this is x squared. It follows the rule nicely. So this is 1 over root 5 When we square this, it becomes 1 over 5. Okay, this is good. And in between, it's going to be the product of the two, but we just switch the sign. So 3 times this is going to be 3 over root 5, switching the sign. So this is indeed a difference of 2 cubes. So essentially, the examiners are being fair to students by putting that rule. A student should actually find out themselves. So when we really want to make this question a higher grade question, we would actually just write this expression and ask you this. You should see for yourself what this is. So again, it just says be aware. It can come. Right, so we are told to express this as a minus 1 over 25 times the square root of b, where a and b are rational numbers. Now, a rational number, we know that it's a number that can be expressed as a fraction of integers. Great stuff. So we write what we are given. So this is 3 minus 1 over square root 5 into 9 plus 3 over root 5 plus 1 over 5. Alright, so that is the 1. So this is equal to, so this is the difference of 2 cubes. So we show that. This is what this is going to be. So basically 1 over square root 5 cubed. Oops, no. I'm talking about 3 and I'm cubing. So basically we just take this bracket and cube those parameters. Nice and easy. So we get 27 minus, this is basically 1 over root 5 is going to be 5 root 5. Okay, please, arithmetic guys, there's no excuses. But now we see that this is a rational number. So we literally rationalized that denominator. So we rationalized there. So this means what we do here is that we're going to have 27 minus 1 over 5 root 5. All of this we multiply by 1, which is made up of the radicals that we're trying to get rid of. Okay, so I'm just gonna continue this side to keep some space nicely used up. So what we get here, we get basically 27 times 5 root 5 over, not 5 but root 5 over root 5. Alright, FOIL method, minus 1 over, now this time 5 times root 5 is going to be, sorry, root 5 times 5 is 5. 5 times 5 is 25 times the square root of 5 at the top. Or we can easily just write this as 1 times root 5 is root 5. Then we know that this divides to 1, so it's as good as not there. So this means we've got 27 minus, now we factor out the 1 over 25, so that the root 5 is here, as it is proposed. So please guys, remember the proposition. We try to drive this into that proposition, and so this is the answer. And we know that 5 is a rational number, and 27 is also a rational number. Nice and easy. So this is the essence of this question 1. This is now the exam itself. Okay, again, it's not truly a standard grade question when it is given like this. It makes it a standard grade question. But if they did not put the rule, then it would become a higher grade question, because you would have to inspect what you are given and decide what it represents. Okay, so be very careful guys. Some very basic concepts can complicate a student's life who is not aware of what they need to know or what they should know at a given point in time. So watch out. Difference of two squares, difference of two cubes is quite a popular thing for the arithmetic / algebraic applications in question 1. Okay. So we're scoring 5 marks. So obviously the way we wanted it is good. The technique of rationalizing is also good. Using the difference of two cubes, good. Perhaps 2 marks here, knowing that it's going to be 27 and root 5, perhaps that would be 2 marks. Okay, easy 27 marks otherwise. Right, let's get to question 2. So question 2, we are given a quadratic number pattern. So this is easy quadratic sequence starting from 2 to 7 to 16, and then the last term is 8, 6, 2. Of course, we know there's going to be the sequence of the first differences. Right, so this is 5, this is 9, and this forms a sequence, and we know there's going to be a second difference which is supposed to be constant. Okay, so we don't need an invitation to do that, guys. We do it straight into 2BS. So 2.1 says we need to write down the fourth term of the quadratic pattern. So all we simply do, we just add these terms nicely. So you see, once you get comfortable with this, you start to use techniques easily, with ease. So we just add those. So this is 16 plus 4, 20 plus 9. So that becomes 29. Okay, so we can just say T4 is equal to 29. We get our mark and move on. 2.2. See, these are warm-up questions. Determine the general term of the quadratic pattern. Again, another warm-up question. We know that 2a is the constant second difference. So this implies that our a, maybe not like that, but essentially a is equal to 2. Okay, which implies that 3 times a, which is 2, plus b should be the very first term of the first differences, which is 5. Therefore b becomes -1. This also implies that a, which is 2, plus b, which is -1, plus c should give us the very first term of the quadratic pattern, which is 2. Therefore c should be 1. Right. So therefore Tn is going to be 2n squared minus n plus 1. Okay, we should not be happy we got it. Let's check this if it represents our sequence. Term 1, if we put a 1 in here, we get a 2 minus 1, that's 1. 1 plus 1 is a 2. Okay, good. Let's check a non-contiguous term. Term 3. This is going to be 9 times 2, 18. 18 minus 3, that's 15. 15 plus 1 gives us 16. So we know this is good. So these ones should be good too. That's how we score those 4 marks. So 2.3. Now it says calculate the number of terms in this pattern. Okay, standard question as well. Tn is equal to 2n squared minus n plus 1. Now Tn is the nth term, which is 8, 6, 2, which is the last term, equals 2n squared minus n plus 1. So we see that this is a quadratic, so we write it nicely. Then we transpose this, it becomes minus 861 equal to 0, which also implies we almost always are able to factorize. But if you're not too strong in the technique, you leave it alone. Let's go to RW. So we just type 861 onto our calculator, which gives us 861. We shift and fact this. What do we get? 861 shift fact. We get 3 times 7 times 41. Now obviously we want 1, the difference to be 1, so we can multiply these. We get 21 and 41. We know 21 times 2 will give us 42, minus 41 will give us 1. So we see that that should be 21, and this should be 41. Now the one that is going to be big eventually should have the sign of the middle term, whereas that one will carry the opposing sign. Again, you don't show this, guys. This is rough work. You don't do it, but you can write it in the same page provided you indicate this is RW, which is rough work. So this therefore concludes that n cannot be equal to minus 41 over 2. It has to be a whole number. Why? Because n is an element of natural numbers. So what do we say? We can say therefore, therefore, now man can detain so bingo. There are 21 terms in the pattern. Okay, I don't know, sometimes my brain wants to move faster than my hand, and therefore the hand kind of drags along. This is what messes up my writing actually. Yes, it's not beautiful, but it's not too bad either. You will see when I'm relaxed, it's actually not as bad. So substitutions, remember every time we factorize, and essentially we answer the question, whether we give it here or in the final conclusion. It's not a big deal, but remember this was an English question. Sometimes an English answer is good. This was a means to an end. Okay, be very careful. So this is easy, 8 marks, more like a warm-up question 2. Not a difficult one at all. Okay, right. Of course, you can use the quadratic formula if you feel overwhelmed by the factorization. But I would advise students to master factorizations. It simplifies life a lot more. In fact, you become more clear in your head when you know this. Now, given the geometric series, so this is GS, which is 2 plus 6 plus 18 plus 54 plus, and then it continues. So if this is a geometric series, we know that R is going to be 6 over 2, which is equal to 3. Very important. R is greater than 0, so this is a divergent geometric series. We need to know this. So 3.1.1 says write down the general term of this series. Well, we know that Tn is going to be A, which is 2, times R, which is 3 to the n minus 1. So the question said write down, so we stop there. So we have 3.1.2. It says we need to find the value of m, but now the question says calculate. So we need to show a calculation such that sigma of 2 over 3 times 3 to the exponent n, starting from n equals 1 to m, is equal to this. So we are given the sum. So now we need to find what is the last term. All right, okay, the position of the last term, by the way. Nice and easy. So what is this? If we look at this, this is the same as 2 times 3 to the minus 1 times 3 to the n, which becomes 2 times 3. Same basis, we add exponents. So this is essentially the same series as the one we had. It's just that the examiners are playing a trick by taking down this 3 so that you don't see that you actually have the same thing. And of course, we know that, well, Sn in this case is going to be A into r to the n minus 1, all divided by r minus 1. The reason we're choosing this is because r is greater than 1. Okay? At the same time, just always remember that what is the base of that power is always going to be r. Okay? But be very careful. Be very careful. Alright, so this implies that Sm is going to be equal to basically A into r to the m minus 1 all divided by r minus 1. This implies now Sm is basically 59048 equals, the first term here is 2 into r, which is 3 to the m minus 1 all divided by 3 minus 1. Now we know that this dude will take care of that nicely. So we've got 59048 equals 3 to the m minus 1. We isolate 3 to the m, we add 1, it's going to be 59049. Now we go to our W, say 59049 equals 59049. We shift and fact. Let's see what the calculator says. 59049 shift fact. This gives us 3 to the exponent 10. So this implies that 3 to the m is basically equal to 3 to the 10. Same basis, we take the exponents. So that's it. It means the last term is the 10th term. Again, we don't show this, or if we do, we put it under RW, so that if we did not indicate that please see RW, then no one comes here. Okay. Right. A very nice question. Again, this is more of a standard examination there because we apply algebra and all the things that you know. So essentially, guys, we can say here substitutions, yeah, and knowing that the number of terms is going to be m is good. Changing this into the exponential form is also a key step, and our answer. So those are the 4 marks on offer there. All right, 3.2. We are told the first term of an infinite geometric sequence is 3 and the common ratio is a half. Determine the value of the third term of the sequence. It's just 1 mark. So, well, we know that Tn here is a, which is 3. R is a half, n is 3 minus 1, right? So this is 3 into a half squared. This is 3 into 1 over 4, which becomes 3/4. So we can just say T4 is basically, no, T3. t sub 3 is basically 3/4. Because this is 1 mark, so a question that says determine, we can actually do it by inspection or assume we did it by inspection. But we actually, had to perform a calculation. But be careful when the question says calculate or show. That's a different story. Okay, so this was, 3.2.1. Okay, so this is 3.2. Okay, good. And then we've got 3.2.2. It says determine the value of the sum to infinity. That's easy. Sum to infinity is a over 1 minus r, because r is a proper fraction. So sum to infinity here, a is 3 divided by 1 minus a half. So therefore sum to infinity is going to be, this is a half flip, it's going to be 2 times 3, which is 6. Again, you can use the calculator to get your business sorted. All right, so again, these are just warm-up questions, guys. Substitutions, answer. But remember, substitutions only get a mark if we see a formula. If we don't, we can assume that you are copying. But since we are not too sure, we may still give you the final mark, the final answer. But penalize either not following instructions or possibly copying, but perhaps running out of time to copy the whole thing, because the instructions at the beginning are very clear. Okay, so we've got 3.3. We are told if powers of 6 is, not really is, but are removed from the sequence. Now we've got the sequence here. What is this sequence? 1, 2, 3, 4, all the way to 8,000. These are natural numbers. Now the sequence of natural numbers is an arithmetic progression with A is 1 and D is 1, because they just differ by 1. So this is good. So we don't have to worry about it. And then we're told here to determine the sum of the remaining terms. Okay. So now I would rather someone says the pure powers of 6, because we can still get multiples of powers of 6. For example, 12 is a multiple of powers of 6. It's 6 to the exponent 1 times 2. This is a multiple. So technically, we want pure, no other numbers that are not necessarily powers of 6. Okay, so we can say original sequence is 1, 2, 3, 4, all the way to 8 squared. Right. So this is therefore an arithmetic sequence, or perhaps arithmetic progression, such that A is 1 and D is 1. Okay. Now what else? Number of terms is going to be 8,000, because with natural numbers, the term number corresponds with its position in the sequence. Nice and easy. So we can say also the sequence of powers of 6 is going to be, the first one is 6 to the exponent 1. The next one is going to be 6 squared, which is 36. The next one is going to be 6 cubed, which is 216. Then if we have got 3, we want the last one. Now this is going to be a bit of a wide, a wild ride. But again, this is nice because this is already 6 cubed. So we can say 6 to the exponent 4 gives us 1,900 So 1296, that's quite small. 6 to the exponent 5 gives us 7776. This is close, so that should be the last one. 7776. Okay, so these are this is the sequence of the powers of 6, which is therefore a GP, right? Because 36 divided by 6 is 6. 216 divided by 36 is 6. So this is a GP with A equal to 6 and R equal to 6. Now the issue is the number of terms here. Now I don't know if we have to show it, because I mean it's just 4 marks. I don't know. So this is going to tax us a bit. I hate it. So what do we see, guys? We need to know the number of terms here. What would be the number of terms? This is crazy, is it not? Yeah. This is gonna be bad. Now we can do it on this side. So if it is GP, this is 6 times R, which is 6 to the n minus 1, is equal to 777.6. Then this is basically 6 times 6 to the n over, we break this up, it's going to be 6 equal to 776. That goes 6 to the n equals, we know that this is 6 to the 5. So therefore n is 5. Okay, so we can put a 5 there. How we did it, it's God's determination. Sometimes when the question is just complex, guys, you just do a side thingies on the rough work and then put it down. Then they can find out for themselves how it did it. So we can say then sum of remaining terms. Sum of remaining sum of remaining terms is such that we have Sn, because they are just as many as they are, equal to n over 2 into A plus L, because this is the arithmetic sequence, because this is the parent sequence. So we will subtract the sequence of these other ones. So this is going to be A into R to the n minus 1, all divided by R minus 1. The reason we're choosing the formula is because R is greater than 1. Nice and easy. So this implies that Sn is, how many terms are here? 8 squared divided by 2 into 1 plus 8 squared minus, this is going to be 6 into 6 to the 5, we saw that, all divided by 6 minus 1. Therefore Sn is the answer. Now we have ourselves 8,000 divided by 2 into 1 plus 8,000. Then this we subtract 6 into 6 to the exponent 5 minus 1 divided by 6 minus 1. Alright, so I'm getting 31,99,467,0. Big numbers. Now, how do you read this number? We know that the first 3 digits at the end, or the last 3 digits, are on the hundreds. And then the next 3 digits are on the thousands. And the first, however many, okay, these ones are on the millions. So this is 31,994,670. Nice and easy. Okay, so this is easy, guys. Not a very difficult question, but one that taxes the student a bit. Because, yeah, you've got to do your things. So, of course, we get a mark for this. We get a mark for this. We get a mark for this. 3 marks. We're getting how many? Just 4. Wow. Perhaps knowing that this is going to be 5 times. That's good enough. However we got it. Whether we give it there or we give it here, or we can show the calculation. But even if we showed the calculation, it would amount to just 1 mark. Okay. So sometimes be economic when the question is too crazy for less. Okay. Just be economic. So this could have been a nice 12 marks where the student is really tested for their knowledge. Okay, not a problem, guys. Let's handle question 4. So question 4 is giving us the vibes. We're told here, Michael notices the following about the number of black tiles and the number of white tiles. Okay, so patterns. Okay, figure 1, we've got 1 black tile. There's how many white? 1, 2, 3, 4, 5. And there's 2, got 1, 2, 3, 4, 5, 6, 7. So they increase by 2. We've got 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means as the black tiles increase by 1, the white tiles increase by 2. So literally these are both arithmetic sequences, technically. Alright, so not a big deal. So we've got these rules now. 1 black tile is going to be 3 times 1 plus 2, and then 2 is going to be 3 times 2 plus 1. Wada. So what I'm getting the vibes of is y equals mx plus c, where m is this. I can see this is constant, right? And the x here is the variable that is changing. This is the number of black tiles as they keep changing. And then the c here is an issue in that c here keeps changing. So this means these are different equations, perhaps a system of equations. I don't know, we will see. So they are not constant, so we cannot say safely this is the case. It's not one single equation, but it's perhaps a system of linear equations. So these things, guys, need to be understood. I cannot overly emphasize these. Messing this up is messing your life up. Let's go for the questions. 4.1.1 says, if this pattern continues as above, write down the rule for the number of white tiles in the figure that has 17 black tiles. Okay, so basically we need to figure out a rule like that. Now we need to study this a bit more so that we can master what is going on. Otherwise, it will hurt. So we need to study these because we'll take forever sorting this up. Now let's see. Tile number 1 here. There's 1, there's 2 here. Okay, this is more like the beginning. So this is perhaps the generic equation, because everything will have to be more like that. The next one, we had a 2 there, so now we have a 1. So how does that work? It means if this was a 2, we subtracted 1, meaning 2, we subtracted 1 there. So from this 2, we're going to have 2 minus 1, which gives us 1. So that's what works there for the first one. The third one, we will have 3, and then we've got 0 there. So it means we had 2 minus 2, meaning if there's a 3 there, we subtract 2 from that constant, which gives us 0. And then when there's 4, then we must have said from that 2 at the beginning, we then subtract 3, the previous number. So 2 minus 3 gives us minus 1, which is this one. Okay, so we can see all of these values coming up nicely. And then when there's 5, we're going to say minus 4 from that constant 2. So this is going to be 2 minus 5, which becomes minus 3. Wait. What am I saying? Okay, these questions, guys, as you can see, you can save time for the easier questions. But to get to this one is a bit silly. It's a bit naughty. So we said with 3, we subtracted 2 from that constant 2, the generic constant here. So we took, first for this one, we just keep it as it is. We don't really do anything. For this one, we subtract 1. We get 1. For 3, we subtract 2. We get 0. For 4, we subtract 3. We get minus 1. For 5, we subtract 4. Yeah. We subtract 4, not 5. So then we get minus 2. So which is this one? When this is 6, we subtract 5 from our 2. So we're going to say 2 minus 5, which gives us minus 3. So this is how it works. So this means 17. It's going to be 3 times 17 minus. So this is going to be just 2 minus 16, which is going to be minus 14. So we put it down. So can you see? Following the pattern, guys, you don't need to do everything. Just study this well enough to know what is the rule. What are we doing for these constants? It means 2 is the generic value. Then we keep subtracting from it using the relationships. So we will sort this up by saying 4.1 with 4.1.1. We know that T17 is going to be 3 times 17, as we can see there, minus 14. As you can see, the 14, we had to study the rule and make sure we understand. This takes a bit of time, so it's not a very cheap 2 marks. It's quite a taxing 2 marks. It taxes our time and it messes up everything. So 4.1.2, we then have to write down the nth term. Again, the question that says write down, we want an answer only, so let's think about it. The nth term of the white tiles if n black tiles are given. So we can use the same rule. Say Tn is going to be 3 times n. There, what are we going to say? We're going to say 2 minus n minus 1, right? Because if this is n, we need to subtract the previous one. So I'm trying to think now. Yeah, we can write it nicely and say this is 2 minus basically n minus 1 to get it right. So this is going to be 3n plus 2 minus n plus 1. So this becomes 2n, because these are like terms, then plus 3. So let's see if this is indeed the one. So again, if we're told to write down, we just simply write it down. But now we can just check these again as they are and say 3 times 1 is 3 plus 2, that's 5. This is 3 times 2, that's 6, plus 1, that's 7. 3, this is 9. This is 12 minus 1, that's 11. Of course, here we can see the common difference here is 2. Right? This is 2. So this is arithmetic, so we can follow that and say Tn is going to be A, which is 5 plus n minus 1 times d. So this is going to be 5 plus 2n minus 2, which is going to be 2n plus 3. It still comes out. So however the student does it, we can use the rule by understanding this portion, or we can just work it out nicely and use our arithmetic don-dons. So Tn is basically going to be 2n 2n plus 3. Right. So we need to clean it up a bit. But at the same time, we can still write it in this manner, but no one dictated how we should write it. So we can write it however we want, because this is not simplified. So this is more simple. Again, not a very cheap 2 marks. So 4.1.3 says how many black and white tiles will Michael have in total up to the 25th pattern. So we need to first add the white tiles and the black tiles and then sum up the total of these tiles. Okay, as you can see, this is now the exam. But the whole thing, I mean the question as a whole for me, this question as a whole, but let's say 4.1 for now, is a true higher grade question because it's not that simple. It's not that standard. So how many tiles in total? As we can see, the black tiles are following the natural number system. So we know that black tiles are in the sequence 1 plus 2 plus 3 plus 4 up until, if there's a 25, then there's going to be 25, the last one. So that's the arithmetic sequence, with A being 1 and the common difference being 1. And the number of terms is 25 terms, because this follows the natural number system. And then white tiles themselves are going to follow a different pattern. Now this one is a bit naughty in that we need to be very careful on what we do here. We need to be very careful. Now we need to start working with those numbers. So we know that this is 5 at first, plus 7, plus 9, dash, dash, dash. Now the one with 25 we need to calculate. So this is basically going to be 3 times 25, minus, now if this is 25, we're going to say 2 minus 24, right? Which is minus 22. So this is 75 minus 22, that should be 53, right? Yeah. 75 minus 22, yeah, that's 53. So the last one here is going to be 53, like that. Again, we see this is the arithmetic sequence. Maybe we can understand here, this is arithmetic series with A1, D equals 1. Here, this is an arithmetic series with A is 5, and then D is 2. And of course, here the number of terms is basically 25. And the number of terms here is going to be the last term, using the rule that I once showed you guys. The last term minus the first term, right? If the common difference is positive, we're going to add it. So it's the last term minus the first term plus the common difference. So this is 53 minus 5. That's 48, and then we add 2. Then we divide by 2 again. So it gives us 25 terms as well. Okay? So this is the shortcut. Arithmetic series, you take the last term, you subtract the first term, you add the common difference when it is positive and divide by it. If it was negative, you would also subtract it and then divide by it. So that's just what we do there, just to make it easy, because again, there's just too much. So what are we saying here? We want the sum total of this tiles. So this is again similar to the question we just did here, but this time we're adding everything. Okay, so we can say, well, the sum total here is going to be n over 2 into a plus l plus n over 2 into a plus l, okay? Which implies that Sn is going to be, now the first one is 25 over 2 into 1 plus 25. Plus this is 25 as well over 2 into 5 plus 53. Right, therefore Sn is going to be right. So this is basically now 25 divided by 2 into 1 plus 25 plus 25 over 2 into 5 plus 53. So I'm getting 1401. So we can say therefore there will be a total of 1401 black and white tiles. Easy peasy lemon squeezy. Let's see again, did I do the right thing here? 25 over 2 into 1 plus 25 ne? Plus 25 over 2 into 5 plus 53. Hayi ke ngoku 10 ndathola impendulo ezingafani ngoku. Hayi yangu 1050 ngoku. Hey, hayi ke ngoku andisayiqondi kakuhle. 10 guys ndathola impendulo ezingafani. Khawuthi ndiyiphinde ingathi ifuna unilinga ke ngoku. 25 over 2, hey, wena 1 plus 25 plus 25 over 2 into 5 plus 53. 1050. Yo, okay, it looks like I punched some things there. Again, guys, as you can see, it's so easy to get things wrong. But I will take what I get because my plan looks solid. Could be wrong because of some mistakes. As you can see, they just like to creep in. But the work is quite straightforward. So how do we score these marks? Of course, the total. This one. The number of terms of each. Was not that cheap, okay? It's as simple as that. But there's more areas, honestly speaking, where we could score marks. For example, this term here, we had to calculate it compared to the others. So yeah, as long as it is done, guys, it is done, okay? It is done. So let's see. Let us see. Right. I think I've answered this question nicely, unless something is really missing. But yeah, whatever it is, it's over. 4.2 says, which term of the series, okay, so we've got a series with 19 plus, now what I do here, I change this to a improper fraction. So we just take 5 and multiply it to 18, and it's 91, then we add that one on the numerator, so it's going to be 91 over 5. Plus, we then take 5 and multiply that by 17, it's 85. Then 85 plus 2 gives us 87 over 5. Again, guys, this thing was taught, I think, in grade, I think it was sub B, grade 2. So, I mean, if you choke here, hi guys, you are hopeless. Believe me when I tell you that. Because this is grade 2 stuff, arithmetic, okay? So, again, guys, since we know that we have worked a lot with the geometric and what, this is most likely an arithmetic, right? But we could be wrong. Let's see, 91 over 5 minus 19. 91 over 5 minus 19. It gives us minus 4/5. All right, let's see, 87 over 5 minus 91 over 5. It also gives us minus 4/5. So this is indeed arithmetic. So now it says, which term of the series is the first negative term? Okay, easy. So, well, we need the nth term that is going to be negative. So here we can say Tn here must be less than 0. Right, this is the rule. So what is Tn is a plus n minus 1 times d less than 0. So this also implies that we've got 19 plus n minus 1 times d is minus 4/5. 4/5. Right, less than 0. And we saw that the common ratio was negative, meaning the gradient of the equation here is negative, meaning it's a decreasing function. So obviously we expect something like this on the Cartesian plane. This is n, this is Tn. So we expect something like this. Of course, knowing very well that this always starts from term 1. And the part that is beyond or perhaps before term 1 does not exist. The only part that exists is this one. So we just want the very first term that becomes negative. What is that term? Now, I don't know if this question wants the term position or the value of the term. Yeah, this is where sometimes you just wonder if these people ever look at these questions and perhaps determine if this is good or bad. But again, we can look at the mark allocation and kind of find out. If we're looking for the term number, this is roughly 3 marks because we're going to use one single step here. So this means we need to take it a step further to earn 5 marks. So this is indirectly suggesting we actually want the value of the term rather than the position, meaning we want this one. So the question is on Tn rather than n, I suppose, for 5 marks, because for 5 marks we cannot get all those marks. Okay, this implies now we've got 19 minus 4 over 5 n plus 4 over 5 less than, why did I have less than or equal to now? You see? Easy silly mistakes. Just love the attention, guys. So this implies that we've got minus 4/5 of n is less than, let's add those two up. Okay, so this is 19 plus 4/5. It gives us 99, so this becomes minus 99/5. So we can say this implies that n this time is going to be greater than, because we're going to divide by negative. So we just simply divide this by 4/5. So I get 99/4. Right, I would like to continue on the other side just to save some space. So what does this imply? Now remember, what is this 99 over what? This is 24,75. So we can say, which therefore tells us that n, now this, we take the nearest whole number greater than this value, which is going to be 25. So if n is 25, what do we say? We can say then T25 is basically A, which is 19, plus 25 minus 1 times T, which is minus 4/5. So we can say therefore T25 is, so we've got 19 plus 25 minus 1 into minus 4/5. What do we get? We get minus 1/5. Okay. So siyabangena ngalo Jesu, uyayiqonda. Understand, it's like this. So this is indeed, so what we can say, therefore minus 1/5 is the first term to be negative in the pattern. Was it in the pattern or in the series? Okay, be able to write a bit of maths in an English sense, of course, because time and space doesn't allow for a proper English sentence. We are just bringing it into the fore, but it's not really a necessity. All right, to be negative in the series. Okay, so that's the thing. So technically, I suppose this would warrant 5 marks, because this would be 3 marks. First of all, to write the rule here is good. And of course, the common difference. This is what matters here. Finding it out, and essentially finding n. This would be 3 marks. The rest of the gymnastics, nobody cares about them. And then, essentially, finding this term, I would believe, is the answer there, and perhaps substitutions into the formula to kind of work out the term. Because for 5 marks, I think the physical term, not just the term's position, is necessary here. Okay, otherwise, whatever is the plan of the examiners, it will remain the plan by those examiners. Okay, guys, we seal this one. Damn it. I'm on mosh. I know when I flirt with the limits, this is what happens. Okay, folks, we are scoring some easy. Okay, not easy. This one was a bit challenging. 14 marks, but I love a question like this. This is beautiful. I can do what I often don't like. Yeah, that one. and is a bright color, is a bright color of a heart. So yeah, this one I love. It brightens my smile. Yellow under was gold. Yeah, this one is beautiful. The examiners know how to pick us. But I just don't like the vagueness of this question. This one is quite vague as to what it wants from us. Okay, even this one is somewhat vague, but I guess the part that says total, I would perhaps accept. But the other one, okay, maybe we can say this one maybe once, but this one is like, what are you looking for? But the mark allocation is not such a bad guide either in trying to tell us what are we supposed to do. Okay, guys, that's it for sequences and series. And as you can see, they are quite interesting because they were done in term 1. So they have to come hot. I always tell students that whatever was from term 1 is going to be a bit challenging in term 2 exams, and perhaps even more challenging in the term 3 exams. But of course, the finals are always the one that finds students over-prepared. In a way, they would look easy, although they are not exactly easy, okay? Okay, let's do question 5 without wasting time. So question 5 says, f of x is given by x squared plus 2x minus 8. So we know that the coordinates of c is going to be 0 and minus 8. Just a constant there. We already know this is what this is. And then if we factorize this thing, it's going to be 4 and 2 plus 4 and 2. So this is going to be minus 4. This is going to be 2 at b. Okay. Please, guys, this is easy. We should be able to quickly figure out these things. Then, what do we see? Y equals mx plus c, but we know that c is as good as minus 8 because that straight line cuts there. Okay, these are sketched below. A and b are the x-intercepts of f. We see that. C is the y-intercept of both f and g. Excellent, we can see it. D is the turning point. This is key to know. So we can do whatever we know how to do to find the turning point. We take the average of these two. So 2 minus 4, that's minus 2. Divided by 2, it's minus 1. So we'll have minus 1 and take minus 1 in there. This is 1 minus 2. 1 minus 2 is going to be minus 1. Minus 1 minus 8 is minus 9. Okay, so sometimes, guys, be very, very comfortable here. There's no excuse. And then this p is easy because we'll just substitute this value into the equation and find out the corresponding y value. So it's as easy as that. So our task here is just to find the gradient, which we can because we've got 2 points. We've got C and A. So it means we are ready to do our business here. So we can go for it. 5.1, write down the value of PC, answer only. So it means we need to substitute the minus 6 into the original. So we've got minus 6 squared plus 2 into minus 6, then minus 8. So we get 16. So we'll just write P is 16. Okay. Nice and easy. So the examiners are trying to just break the ice because, yeah, with this parabola, it's usually stones, sticks and stones, boys and girls. Determine the coordinates of A and B. We know how. So we know that A and B are such that f of x is equal to 0. Why? Because these are the x-intercepts. Right, this implies, what is this? This is x squared plus 2x minus 8 equal to 0. I don't know why I'm squashing myself here. I should not. So we've got x squared plus 2x minus 8 equal to 0. We now can factorize the business. Can you see, once you know how to factorize, your job becomes very easy. So we know that x is basically a 2, or x is minus 4. Now looking at these two, we can see that a is going to carry minus 4. The corresponding y value is 0. And b is going to take 2 and 0 because of its position. Remember, we need to show the ordered pair because the question said coordinates. It didn't say x coordinates. It said coordinates, meaning both x and y coordinates. Don't lose out, guys. So this is a mark. Substitutions in the business, whenever we factorize, we get a mark. Now showing up with our ordered pair gives us the extra marks, okay? Nice and easy. So 5.3, we are to determine the coordinates of D. So, well, D, guys, is as easy as, we can use issues like x is equal to minus b over 2a is to y there equals 4ac minus b squared over 4a, or any other means necessary. I mean, this is an open-ended question. We can use differential calculus and stuff. But what I like is to write my equation in standard format. I'll just write f of x in the turning point format. I can see a is 1 already, so I don't have to worry about it. I just take x. Then I have the coefficient of x and take the original sign. So this is going to be plus 1. Then I put it under the square. And the next thing I'm going to say minus 8 and immediately subtract this half squared. So basically it's minus 8 minus 1, which is minus 9. You can say therefore D is going to be minus 1 and minus 9. Done. You can sweat here, but look at the mark allocation. There's not a lot you need to do. So literally doing the completion of the square or writing it in turning point format is key, and presenting those coordinates. All right, but again, you can go through all the things you can do. You can actually go to town while practicing, of course. Don't always limit yourself to just one way of solving during practice. Try to check other ways in which you can answer the same question, just to widen your view and your understanding of the subject. Because there's no point in trying to do time attack, guys, when revising and studying. This nonsense people keep telling you is bad. It's just bad. They don't know it because they're just imagining it. Hardly have they used it themselves, but they will go around behaving like experts here when they have not actually used it. But they just see and hear everyone saying the same thing, and then they go around saying the same trash. Don't do it. At times, guys, there's no point in hearing what people have to say on what you should do to study. If you're a student and you're responsible enough, you should already understand how you do things well. Only a struggling student should be listening to what other people have to say. But at the same time, be very careful. People like to sell you dreams, pipe dreams. They'll tell you all the things that are not practical, but sound very good on paper or from, the word of mouth. But if you want to put those into practice, you lose a lot of time, you lose confidence, you end up giving up altogether because you thought this is a plug and go. No, guys, there's no substitute for hard work, believe me. You only start to do smart work once you've done the hard part. Hard work is just hard work. If you don't do it, you're not going to succeed. Trust me, you're not going to succeed. Because not every trick that you can be taught will help you to understand some tough questions. These tricks only work once you know the hard part of it, meaning you must have done the hard work first, understood it, and saw its limitations and perhaps potential disasters. Then you can look at the smart techniques, which can then simplify that hard work. But without that hard work, even these simpler techniques do not make any sense. So please, guys, don't be caught up in some people's imaginations. Do your thing. Your teachers are good enough already. They teach you how to do stuff. If you follow your teachers, you don't need to listen to what others have to say. Not to say disregard everything. There are some good points, of course, for students who don't have any help, do not have any support. But even those, they know exactly what to do to survive. But then if they want to take it a notch higher, for me, hard work, guys, pays. The rest is just gibberish. It may or may not work. Anyway, let me not preach. I'm not a pastor delivering a sermon in church here. Because those people repeat the same thing multiple times as if the people or the congregants do not hear or do not listen or don't understand. They overly emphasize things and end up projecting themselves in the message of God, which is really bad. Now, I don't want to make maths bad too. Right, 5.4, we need to determine the values of M and C, okay? Well, C is already good. C is basically minus 8, okay? This is the common y-intercept of F and G. That's why we know. But M, we know it's going to be y at A minus y at C divided by x at A minus x at C. So this is equal to 0 minus into minus 8 divided by minus, what did we get there? Minus 4 minus 0. So this is going to be minus 2. Done. Alright, so that is how many marks? Just 2, okay? What a strange thing. What a strange thing. So 5.5. We now have to determine the equation of the tangent of F at point C. Now if we draw the tangent, how is the tangent going to do things there? It's going to do things like this. Yeah. The tangent is doing that thing there. Is tinging, is doing the thing is dengus. I'm sunkrela. Diding must not be coloring me, man. I'm not colorable, you see. I am not colorable. Please, mathematics, do not try to color this guy. He is not the colorable type, you see. This is the type that is uncolourable. So simply doch, do not make me dear Macaria. Okay, there's our tangent. So what do we know? What do we know? Now this is the question for grade 12, strictly grade 12. Grade 11s are not going to know how to answer this question. So this is a strict, so you will never see this question if you're not a grade 12, okay? Only grade 12s know this from differential calculus. Now, well, we know that C is already the y-intercept, so we know the y-intercept is minus 8, so all we need is the gradient. So what are we going to say? We will say, well, at C, the gradient of the tangent is basically equal to the first derivative of 0, because point C is 0. This implies that the gradient of our tangent, now we differentiate our quadratic. When we do this, we get 2. Instead of x, we put 0, and then we will write 2. Now the derivative of a constant is 0, so it's not there. So therefore the gradient of the tangent is basically 2. We can say then the tangent as a line or a vector is such that y is equal to 2x plus, no, we don't even need, because this is good. We can see minus 8 is the y-intercept already. So this is complete, okay? See, smart work, guys. So basically doing the derivative and substituting gives us 1 mark. Finding the gradient is the second mark. And the last mark for putting it together. Of course, you can go through it, the standard approach, but you would end up with the same answer. So sometimes a smart piece of work is somewhat palatable. So 5.6. As you can see, guys, to navigate through questions like question 5, it's not as easy. You don't just do this in an instant. There's a lot of work here. Lots of questions can be asked. So write down the range of minus f of x. So minus f of x basically is such that, so we just multiply the entire function by negative, so we get minus x squared minus 2 plus 8, okay? That's what we're going to have. But remember, guys, this is a reflection of f vertically. So this is a vertical reflection of f. Or we can say about the x-axis. So what happens? We change the y values. So this means this point D, we will just switch because the x values don't get affected. Only the y values change. So that minus 9 will then change to a plus 9. So we can just say the range is going to be equal to the y value is such that y is less than or equal to. This time it becomes less than or equal to because this has been reflected. So it's going to be a grumpy face parabola. So it's going to be 9, where x is an element of all real numbers. I like the set built notation. It's proper, it's mathematical. But some people may write y is an element of negative infinity to 9. So you can still do that. By default, this automatically is only acceptable without qualification when x is an element of real numbers. But I like to write that habitually because when x is not an element of real numbers, it can hurt. Okay, it really can hurt. Or some people may just write y is less than or equal to 9, right? Because we know this turning point would be the maximum when it's minus 1 and plus 9. So the graph would be defined below the turning point and at the turning point. Again, this automatically falls in line for x being an element of real numbers. So when the inequality is floating, it means all real values less and equal to. But yeah, I feel like this technique is more complete for me. But a student can do whatever they are taught or whatever they find comfortable to do. Nice and easy. So easy 2 marks there, guys. So sometimes I prefer, complete things. I prefer complete things than incomplete. But again, one can still score 2 marks for that or that. It's still okay. Just make sure the y value there changes its value because this is a vertical reflection. It becomes a grumpy face parabola. So this becomes a maximum. Then this changes sign. But the x values are never affected by a vertical reflection. They only get affected by a horizontal reflection. Okay, Nice question there, a graph interpretation type question. So 5.7. Now we have to determine for which values of x is this. Okay, now this one is best written like f of x greater than, we transpose the g. So we are saying the graph of f must be above the graph of g. So what we see here, we will see that, well, in this segment, g is below f for the same x values. Right. Because if we look at these x values, just pick any x value here. For example, if we pick that, right, this x value, can you see that the y value on f is bigger than the y value on g? So this is essentially a true reflection of that being greater than the other, right? Right. But here, in between here, if we choose that point perhaps, what we will appreciate is that this y value of g is greater than the y value of x, so we cannot take that. So this happens all the way in between here until this point C, when the switch happens again. We see that from C, this whole shenanigan that happened earlier is happening again, because we will see that this not you, this one. So what we will see again for that particular x value in there, if we choose that one, I know I'm overly simplifying things here, but this is a necessity, guys. Hayi man, kanti itheni ngokuyabanjwa nje, mayingangiqheli kabi kaloku. Singiqhela wena. Sikantlwahela wena man. Utlantena jwala. Batla o tene wa tseba. Jwale re a bona ntwena hore hantle y value there for the same x value ke kgolo ho yane akere. Jwale ho tsho hore tse bohlokwa he di qala hona mona ho c and di tla ka nqena wa bona. Yeah, ho tsho hore jwale dintho tsa rona di qala hona mona, ha re kenyane re ya ka nqane. Right, and then again this is not included because this is not equal to, but we go that way, right? So those are our solutions. So we will write here that, well, x must be less than minus 4, or x must be greater than 0. Nice and easy. What are we saying again? For which values of x, yes, is f of x greater than, because this is what we need to appreciate. This works out nicely like that. Okay, all right, okay. I think we've done due diligence here. It's very easy, it's very nice, it's tasty. It's fantabulous because this one was disallowed. That one was disallowed and everything else was 100%. So we get this one. So we're not saying greater and equal to, so we need to leave them excluded. So again, 5.8. Now 5.8 says, for which values of k is x squared plus 2x plus k equal to 0, have no real roots. Now what is going on? This is essentially the examination, which is essentially the higher grade question. Come on, Wenaman. Higher grade question, right? So what is going on here? So we'll notice that this situation, we do have x squared as we have x squared here. Then we've got 2x as we have 2x over there. But the 8, minus 8 is missing. So this is the only part of the graph that we have. So minus 8 is missing. So what happened? If we eliminated it, it means we must have added 8. So this means we shifted this graph 8 units upward. That's the first thing that we did. So we need to know that we shifted this graph 8 units upward, first and foremost. So this is, let's just get an outline of our graph. Doch, my hand. I want it to be free. Now it's getting caught on the table. So zamunganqinqizeli kakhulu. Okokunqanqizela kuziswa zii-intention tremors. And not trusting myself. So now guys, this graph of ours has moved 8 units upward. So this is at minus 9. If we move 8 units upwards, it means, okay guys, I'm not too sure what is what here, but all I can say is that we are sitting at 1 unit upwards, maybe here. So we are sitting here, so that our turning point is now, let's say perhaps D prime. I don't know if I can say that. Maybe let's say it's just D prime. Or maybe let's call it a new turning point. There was no E here, so we can say this is E, where we've got minus 1 and minus 1, right? Because we moved up 8 units. So this is a hidden vertical reflection by 8 units, okay? Now what are we doing? We're also adding a constant k. So if we add a constant k, this is also still a vertical reflection. So now we want to shift this graph further than this. So now what I'm going to do, I will copy this graph nicely and then shift it further. So there's our graph. Now we're taking it from here, we're shifting it upward. If we shift it 1 unit, we'll have 1 single intercept, but we don't want it. So if we shift it by more than that, this is what we end up with. So this distance is just 1 unit. So if we shift it by more than this, so meaning we shift it more than 1 unit up there, then we will have no real roots, meaning no intersection with the x-axis. So this is good. So it's simply k must be greater than 1. But as you can see, it takes a bit of a toll on us. We need to first shift it 8 units up, then 1 unit up. Sorry, by more than 1 unit up. But because this has already been transformed, so we need to get it right, okay? So that was a naughty question. So k must be greater than 1. Because if we add more than 1 unit, that graph, as it is, will have shifted upwards. Or alternatively, one can use nature of roots, because nobody said use the graph only. So we know that x squared plus 2x plus k equal to 0. We can just say for non-real roots, it is such that the discriminant is less than 0, which implies that b squared minus 4ac must be less than 0. This is now 2 squared minus 4 into 1 into k must be less than 0. This means 4 minus 4k must be less than 0. Minus 4k must be less than 4. So when we divide by minus 4, we can see k is greater than 1. Okay, so again, even if you do this on the rough work and just jot down the answer, it's still acceptable. So guys, don't fail questions of this nature, because if you don't realize, I mean, sometimes students don't understand this graph so well that they can do what I just did. So all you do, just do the common algebraic standard technique, then do it somewhere. For 2 marks, you can write the answer only, except when the question clearly states calculate. Okay, so that's it. That's it. As you can see, guys, what matters here now for 2 marks here would be this situation and that. If of course you've shown the calculation, but if you did not, you still get 2 marks for the answer. All right, guys, that was a nice 18 marks. Okay, the question was not really made too difficult and unapproachable. Made it a bit fair, but yeah, that last question, you need to know things, okay? You need to know things. Very, 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 very important. Very important. Okay, all right, okay. I think we've done everything nicely. So let's get to question 6 and see what we can do about it. So question 6, we are given age of x equals 6 over x minus 2 minus 1, okay? So this is the hyperbola again, more of an exercise, or should we say warm-up from grade 11. Write down the equations of the asymptotes, straightforward. So we know that x should be 2 and y should be minus 1. So for the x1, we always take the opposite sign of that. The y, we take it as it is. Okay, simple. Simple, simple. So this is 6.2. Determine the coordinates of the x and the y intercepts. Okay. For x-intercepts, it is such that basically 0 is equal to 6 over x minus 2 minus 1. Now we transpose 1 to the one side and keep it as a fraction. It is a rational number after all, isn't it? Yes. So what do we do now? We cross multiply. So we get x minus 2 equals 6. Therefore, x is 8. Therefore, our x-intercept is going to be 8 and 0. We can write here for y-intercept, it is such that h of 0 is equal to 6 over 0 minus 2 minus 1. Therefore, h of 0 will be, this is going to be minus 3 minus 1 is going to be minus 4. Therefore, the y-intercept is going to be 0 and minus 4. Nice and easy. Right. So 3 marks, that's that's a rip-off, guys. Come on. Knowing that, and that, and I guess that. Wow, guys, no man, this should be 4 marks, kaloko. Kenny number 14. But remember, guys, the ordered pair, we need to see it. If you don't show it, you lose 1 mark, okay? Now, 6.3. Okay, maybe let's close this argument nicely, as well as that. Right, so 6.3 says we need to sketch the graph. Okay, stuff that we know. So we just zoba the Cartesian plane. Looks a bit too much. Is that nice? Yeah. It doesn't have to be really too big, you know. Yeah, I'm not really happy about my vertical line though. That vertical line looks chicanary. Maybe it's still chicanary, but it's much better, much better. That is the one. Okay, maybe let's extend it a bit. Hayi ke man, sungiqhela wena. Theni wathanda ukulandela wabangwaka amalandela isitrato sasetsakane in the East Rand. Abangumalandela street sinhlanyisa wena. Anyway, this is -1, so we can decide -1 ulapha is the asymptote. So we always dash that thing so that it's a dashed line, you know. And we can write here -1. And then the other one is a 2, so we can put it down here and say the 2 is here. Again, it should be a dashed line. So this is 2, right? Right. Now, we saw that the numerator is positive. So it means the graph is going to be doing things like this. Here. Okay. And that should be 8. It does this thing at 8. Okay. Right. So we take this guy, we copy this guy and put this guy down here and paste this guy. So this is swing at swing. It is nosiqhela kakubi kwethina. Asiqhelwa kakubi thina. Izinto ezingakwazi ukuthetha. Qhela kakubi xa kutheni khona ngoku. Siqhela kakubi xa kutheni into ezingenamlomo. Into ezingakwazi nokuthi zizosiphaphela. Hayi ngeke guys. Kuyahana kuyaladula. Ayikhonakala entweni. Now this is -4. Asiyigqibanga, ndicinga siyiqibile. We can label this as h guys. Noba simbhale phi. Asimbhala apha. Mhlawumbe uzobonakala kakuhle. Igqityiwe hyperbole. Okay, u-x funeka bekhona naye. Simbone yena osithandayo. So 6.4. Okay guys, how do we score marks here? Shape any one of the intercepts and one of the asymptotes. Good. Determine the values of x for which h of x is less than 0 in this interval. So this is basically x less than or equal to 0. So this is what this translates to. So this means we're looking in this region. When is our graph below the x-axis? And we will see and appreciate that our graph is doing that here when x is less than 8. Khalarisha kaloku ntonto nditheni ungathi uresistile nje. Ikhe ngiqhele kakubi ke le nto xa ithanda. So nansiya. So we can see this is only happening when x is greater than 8. That's easy 2 marks again. Yo. For a total of 10 marks. Okay. So this looks nice and easy. Not too complex. Okay guys, so can you see? When you know, you know. When you don't, it becomes painful. So let's take down this question 7. So question 7 says the graphs of p of x equals b to the exponent x. So what we notice is that the coefficient of this power, the power is the base and its exponent. So the coefficient there is 1. So usually this is a. So a is greater than 0. And what do we see? Well, we will see that there's b now. B, which is the base of our power. We don't know about it. But what we know for sure is that the exponent x is an element of real numbers. Yeah, man. So let's look at p on the graph. The graph of p is this one. Now this is a bad sketch because it makes an intersection with the x-axis. So whoever designed this question is, yo, ndizombiza ngamagama mandimiyeke ngisesendimxolela ayikho ke kodwa le irongo lento le. You cannot present this sketch to students because this is not shifted, because once this touches here, we are being suggested the fact that there might be an x-intercept, and if there is an x-intercept, it simply tells us that this graph is shifted, although not shown, and this is a very bad idea if it is not the case, and it's usually not the case. Okay, so a bad sketch, unfortunately. So I already give these people scary. Alright, but now what we notice, guys, that this is a decreasing function. When this is a decreasing function and it appears above what is supposed to be the horizontal asymptote, which is the x-axis, so it means b is less than 1 but greater than 0. It's a proper fraction. So when we solve for b, we expect it to be between 1 and 0 because of this function decreasing. So know these characteristics, guys, so that you don't get to botch these questions. And of course, if this is unshifted, the coordinates of q is going to be 0 and 1. We know that. Because if we substitute 0 for x, now any base to the exponent 0 is 1. So p becomes 1, the y value, p of x. That's good. Right, and the inverse. Now the inverse of p, that point q is the inverse of point r, so which is going to be 1 and 0. We just switch x and y. And again, if the original is a decreasing function, the inverse also becomes a decreasing function. Great stuff. So k with minus 3 and 27 lies on the graph of p, and s lies on the graph of the inverse. Now q and y are the other y-intercept of p, and r is the x-intercept of the inverse. Nice and easy. Okay, guys, we can just go and kill it now. Determine the value of b. So we expect it to come out negative. So we know that p of x is b to the exponent x. Now we take a point k, which is minus 3 and 27. This is going to be 27 is equal to b to the minus 3. All right. So this implies that we have sinadonge up, so 27 equals 1 over b cubed. So this is 27 over 1. So I just want to do some algebraic don't. Remember, guys, let your brain work sometimes. Do not allow it to lazy around. So b cubed is going to be 1 over 27. So basically what it would just do, you can consider this as just flipping these. B goes with 1, 1 goes with 27. Nice and easy. You flip that, you can write b over 1. No issues. B over 1 is just b, or b cubed over 1. Now we can actually continue with our exponential parade. B cubed is basically 1 over 3 all cubed. Now once we have the same base, the same exponents, it means the bases are the same for these things to be equal. So B is a third. And indeed, it matches exactly the parameter that we had in mind. Of course, could have done anything, but I just wanted a bit of algebra. Remember, you want to wake your brain up a bit. So at times when you can handle a calculation without using a calculator, just do it. To just allow your brain to wake up. Because the moment you let it shut down, you will lose 100%. So we're getting 2 marks here. Substitutions and the answer, guys. The rest of the gymnastics are your own indaba. So 7.2. Determine the equation of P to the exponent. The inverse. Okay. So we know that the inverse of P is such that we switch X and Y. Now we can write P as it's supposed to be. So this is a third to the Y. So let's just show you the steps. Although I can just quickly jump into the answer by inspection. So we know that we will introduce logs. Now, using log rules, we know that log x, the exponent, is offloaded. Right. Now, we divide by this, we can isolate y. Y is going to be basically the log of the number on the numerator with the base like that. Of course, guys, you can jump to the final answer. You get 2 marks for the answer only. But if you show the calculation, switching the 2 and giving us the answer is as good as this is. All right, 7.3. Now we need to write down the coordinates of Q and R. Again, we've done it. So Q is 0 and 1. And R is going to be 1 and 0 because these are inverses. So 1 mark for each. Nice and easy. 7.4. Now it's one of those questions. 7.4.1. It says, for which value or values of x will this be the case? Okay. Now let's look at P. We're saying P of x is less than or equal to 1, but greater than 0. So this happens here, right? It is happening here. Siyayibona nje sijongile banantsi apha. Phayana ngu-1 ndithi bese isiza ngapha. Uyeke nje bese sketch sibi. Hayi wena man. I think these updates are not really doing good for me. They're messing up my things. Okay, guys. So there is the feasible region, provided this doesn't touch the x-axis. So we can see that it is 1 and less to the right. Okay, so we can just write x must be greater than or equal to 0. Is easy. So this is just 1 mark. Okay. 7.4.2, we need to know that this must be less than minus 3. So when is it minus 3? Here. There. So this is already given. So we know that x is 27 and the graph is at minus 3. Now we want it to be less than minus 3. So this region is this one. It's this region right here. Okay, so again, we can write x must be greater than 27. Nice, nice, nice. Again, these are fairly standard grade questions, nothing special about them. There's a 7.5, Haibo, Jani Jalo. So there's a 7.5. 10 was angapheli questions. T is a point in the first quadrant such that TQ is parallel to the x-axis, meaning it's a horizontal line. So TQ is stuff like this. Okay, so far. Don't know where it ends. And then TS is parallel to the y-axis, meaning it's a vertical line. So literally we just continue like that. Okay. So this is out. So this is point T. Now we need the coordinates. Now for a line that is parallel to the y-axis and a line that is parallel to the x-axis, what do we know? This is having the same y value as Q. It has the same x value as S. Okay, maybe let's write this a bit better. So this is going to be 27 and 1. Okay. Now, what is the story? Calculate the area of triangle QTS. So we just complete a triangle here. And of course, the x-axis are always perpendicular to the y-axis. So this is good. So this is our triangle of activity. So how do we sort it out? We know that area of triangle QTS is going to be half base times the perpendicular height, which is going to be a half. The base, we can do that calculation, is going to be 27 minus 0 because it's a horizontal line. Perpendicular height is going to be 1 minus 3 is going to be plus 3, which is, let us see now, 0.5 into 27 into 4. This gives us a 54 square units. All right, I was just pressed for space, guys. I hate to write like that. It's not advisable to write like that. It constitutes what we call illegible work. But hey, so this calculation, guys, is key, and that calculation is key. And the answer provided, we write the proper units. You can write units squared or square units in words. That is fine. How many marks here? 4 marks. Okay. We can easily say the rest of these substitutions using the formula. That's the 4th mark. But it should be 3 marks, to be honest. Oh, yes. This is 3 marks, but I think before we start this question, we need to state somewhere that point T is basically 27 and 1. And we get a mark for this. And that's the 4th mark. Okay. Please, there has to be something like this stated. Because if we don't state what are the coordinates of T, then none of these calculations will make sense. Okay. Yeah. All right. Otherwise, guys, this was a nice 12 marks. Anyway, this is the edge. Yeah, whatever, guys. Sometimes, you know what, we cannot force izinto ezingafuni ukuforstelwa. Let's get to question 8. Question 8 uthini ke yena? So 8.1, we need to differentiate from first principles. We already know that the first derivative is the limit as h tends to 0 of Sir Isaac Newton's quotient, eunomos. We write the formula, so this is equal to implies f prime x equals the limit as h tends to 0. We then substitute. Now when we see x, we put x plus h, and then this is squared, and we write that expression minus f of x, we write it as it is, divided by h. Okay, so this implies that f prime of x is the limit as h tends to 0. We expand, so we get 3 into x squared plus 2xh plus h minus 2 minus 3x squared plus 2 all over h, which also implies that f prime x is the limit as h tends to 0. We expand further, so this is 3x squared plus 6xh plus 3h minus 2 minus 3x squared plus 2 over h. So this guy and that guy, they fight and die, and that one also follows suit. Okay guys, simplify systematically. Don't rush, don't be impatient, follow the steps. Okay, so what do we end up with here? We end up with just 6xh plus 3h over h. The end result is very important to show, because sometimes some very technical questions can come from these things. So don't take these things for granted. So what we can do there, we want to get h in the denominator out. So this is what we end up with. Sorry guys, this is 3h squared. This was meant to be squared. Can you see? Easy mistakes to make. They mess up everything. Alright, over h. So this and that divide to 1. So this is the first derivative as the limit as h tends to 0 of 6x plus 3h. This implies that f prime x is going to be 6x plus 3 to h. We now drop the limit and then conclude that this is just 6x. And of course, using the power rule here, we know that f prime x is just going to be 6x. So you already know the answer. Just make sure you get to it. You see, what matters is just getting that answer, because you already know what it is. But now we have to follow the procedure. How do we do this, guys? Substitutions into the formula is a mark, right? Simplifying everything to that step, that's a mark. Factorizations, that's a mark. Dropping the limit when you substitute, that's a mark. The final answer. So that's how we score 5 marks there. Sometimes 6 marks, for this portion. Right, good. Now, that's it, guys. That's it. So we've got 8.2 and we've got 8.2.1. It says we need to find the first derivative if this is the case. Now this is easy to differentiate, we just do it. So f prime of x is, now it's going to be 12x. Now from 4 we subtract 1, that's going to be cubed. And then we're going to have minus 2 times a half is just minus 1. So this is minus x. And then this is going to be just like that. 5 is 0, so we're out. So we get a mark for each one of those derivatives. Nice and easy. So 8.2.2. we need to find dy dx if this is the case. But now the problem is that x is under the radical and is also on the denominator. So that's not ready for differentiation. So we need to first sort it up. So what do we have? Y is equal to, we write it as it is given first, over 2 minus 1 over 9x cubed. So this implies that y is equal to, we can factor out the half and say this is x to the half, right? To get the radical out, minus 1 over 9, we can factor it out. This is now going to be x to the minus 3. So this is proper. So we can say therefore dy or dx is equal to, we now differentiate, this is going to be a quarter of x to the minus a half, right? Right, plus, we put a 3 there, it's going to be a third, of x to the minus 4. Again, guys, you may not like these negative exponents and perhaps try to do it as mathematics prefers, that we never write negative exponents at all. We would rather have radicals than negative exponents. So this could be written as dy dx is 1 over 4 root x, right, plus 1 over 3 to the exponent 4. So that answer can be presented like that. That's it, okay, but there's nothing wrong with leaving it here. So what do we get, guys? We get a mark for this, we get a mark for each of these. 4 marks, then it means we get a mark for that as well. And that's too much. 3 marks is good enough here. But hey, when you are being rewarded for your patience and your charisma, why not? Okay, so we are again given that, so we need to solve f first because we do not have it nice. So this is 2x squared minus 3x minus 5 all divided by x plus 1. So this implies that f of x is, we can factorize the numerator and we cannot do anything about the denominator. So this is 2x, this is x. Now what can we do? 5 and 3, so this should be 1. This should be 5. Now that must have the negative. This one must have a positive. And nicely we will see that this term will divide that one in the denominator, so that f of x is basically 2x minus 5. Therefore the first derivative is just going to be 2. Of course, the gradient of a straight line is the coefficient of x. Nice and easy, guys. So when we factorize, we get a mark. Simplifying f is a mark. The derivative, good, 3 marks there. Alright, so let's do 8.3. Now 8.3 says the tangent to the curve y equals minus x squared plus 4x. This is a parabola that passes through the origin as the y and x-intercept. But now if we factorize here, we will get x as 4. So this is a parabola like this. Right. This is a parabola like that. So please, guys, know these shapes. Just look at what you are given and be able to tell what the shape is going to be. It is a crime not to know these things properly. because it means you guys are just wheelbarrows. That where your teachers leave you, this is where you stop, and that's not right. Okay, so that's what we have. Okay, that's what we have. Yikes. It is what it is. You know. Right, so we are saying now there's a tangent here. Now such that this tangent itself is perpendicular to this line. Can you see a concept from analytical geometry? So this already emphasizes the fact that when you're preparing for a paper 1 exam, don't think you're not going to read paper 2. Always though, try to read what is relevant. This is the usual thing, but do look at theorems. You get surprised at times for optimization or anywhere finding yourself needing to use the proportionality theorem, for example, if you are given a shape. So be ready. So now we know that basically the gradient of our tangent is going to be the negative reciprocal of this gradient. So if this is a half, this should be -2. So this is suggesting that the gradient is negative, and this can happen where? After the turning point, right? This can only happen after the turning point. And what is the turning point? It's the average of the two, so it's going to be 2 right here. So this means our tangent is on this side, literally, perhaps at this point. Can call it the point of tangency, this being the tangent. Okay, guys, be very creative, enjoy your studies so that you can do these things effortlessly. The sketch diagrams of what is given should just come easy. Okay, it should come easy. And this particular line we are told about, this is the one. Right? That is the line that we are being told about, and we are told that these two are perpendicular. So be comfortable doing these things, guys. I mean it when I tell you this, because you will go very far with these things, and then we know that this is -4, it's y-intercept. Can you see? And we know that a positive gradient with a negative y-intercept, its x-intercept is certainly going to be positive. That's why I know it's going to cut on the positive x-axis. Can you see the notes I gave you on the previous lecture, or should I say tutorial, on analytical geometry? Comes in handy right now. So this is the state of affairs now. So what we need now, we just need the port. We just need the port x is to y. So what is that? We need that big time, because without the port we won't be able to find the y-intercept of the tangent. The gradient is easy, but we need to set up the y-intercept. Okay, so first of all, guys, we can say the gradient of the tangent is going to be -2. Why? Because we know that the gradient of the tangent multiplied by the gradient of the line should give us -1, given that these two are perpendicular. So that is the rule that we used. So if you're not comfortable doing this, guys, as I tell you, this is acceptable in paper 1 to furnish reasons when you are lazy to try and show this long, lengthy and boring calculation. The one thing you don't want is to end up just guessing the gradient. As much as you may have found it the right way, if there's no justification, for me, that's dangerous, okay? Because where did you get it? Remember, the exam is all about what you are doing and where you're getting it from and where it's going. We don't care that we know. We also want to know, do you know? Rather than guessing, because if you're guessing, we're not interested. So follow the rules, guys. This is the etc. part of our instructions. That whatever we used to determine our answers, we must show. We are showing it rather than to waste time doing a long, lengthy, tiring calculation. Okay, numero uno, or numero una, is 1, is the 1. So we can say now at point at the point of tangency, which we call the port. Please don't find yourself saying port without explaining what it is. First introduce it, then use it. What do we know? We know that the first derivative, but now this is not f, because this is given in terms of y. We know that dx, dy over dx. Please guys, pay attention to the notation. This is going to be equal to -2. The gradient of that function y is going to be -2. So we're solving for that point. Now we differentiate our quadratic. So this is going to be -2x plus 4 equals -2. This implies that -2x is going to be -6. Therefore, x is 3. Does it make sense? Yes, it makes a lot of sense. That point is right ahead of our axis of symmetry, so that makes sense for it to be 3. It's before 4, it's after 2. So yeah, our calculations are starting to make some sense. We can say therefore y here is going to be minus, we put 3 squared plus 4 into 3, which is, now this is -9 plus 12, this is 3. Okay, you can say therefore the port, now we can say it, point of tangency is 3 and 3. Again, it's a point in the first quadrant, so x and y are positive, so that the fact that they are equal perhaps is a coincidence. We did not expect or anticipate that, but we do appreciate that it is certainly a point in the first quadrant. Now what we can say then, our tangent is y equals -2x plus c, and now we take our port and substitute, which tells us that c should be, this is -6, becomes 9, therefore y is -2x plus 9. Again, we can see that if we were to produce this all the way, it would go quite high, so that makes sense for the y-intercept to be 9. So we are happy, and we are sure that if no mistakes have occurred in our numbers, they then make better sense even themselves. So we get a mark for this and its justification. Doing the actual differentiation and equating it to 2, that's a mark. Right. Finding the port, however we did, that's a mark. So 1, 2, 3, 4. Then this and that. So let's see, 1, 2, 3, 4, 5, 6. Where is the 7? So maybe we can mark these together. However we did them, it's fine. Or individually, still okay. So 1, 2, 3, 4, 5, 6, 7. Yeah. Nice and easy, 7 marks there. For a total of an easy 21 marks, provided we know what we're doing, because if we don't, we are as good as dead, if not dead. Anyway, guys, so that was a nice question. So perhaps we can say slightly higher grade in that. We have to think about the concept of paper 2 to navigate this properly, which I already warned you guys to making sure you keep it close in your chest. When preparing for a math exam, of course, you do the majority of questions to be those of paper 1, but do revise common concepts from paper 2, from Euclidean, trigonometry, analytical geometry. Please know those things. So when you're studying a maths or preparing for a math paper 1, you need to study also Euclidean, you need to study trig, you need to study analytical geometry. Do not go into that exam not knowing these things. As well as when you're writing paper 2, study functions, sequences and series. Okay, maybe sequences and series not so much. Study functions, differential calculus, and algebra. Because sequences and series is more of an application. But hey, I will tell you one thing. You know, anything that has algebra in it, just study it. This means study everything in paper 1. But of course, not as intense as you would. Because you'll just need the concepts rather than the intensity of how those things work. Alright, cotton funamanzi. Alright, I'm under man's guys. Pure water, please. Don't drink all the stupid waters that you buy on the stores and stuff. Just drink pure water, my feet. Especially those who have a borehole, they have the proper water to drink, not this rubbish sold from the stores and all. Okay, guys, what do we have? F of x equals minus 2x cubed plus 5x squared plus 4x minus 3. Now looking at our sketch, we already know the coordinates of C is going to be 0 and minus 3, right? The constant. These should come easy. And of course the shape, because the coefficient of the highest power, which is x cubed, is negative. So the graph has the shape that we expect. Okay, nice and easy. So this says solve for x if f of x is equal to 0. So this is just a call to solve for the x-intercepts. Very easy. Now we need some trial and error. Then we can do this by inspection or synthetic division, whichever we choose to use. But I would rather teach long division as it is in its purest form, so that you can master all those other techniques like synthetic division or inspection. Anyway, so we know that 9.1, we are told f of x is equal to 0, which implies minus 2x cubed plus 5x squared plus 4x is like this. Let's shift you a bit. I hate the drifting, although it looks ridiculous, but that's what it is. Now guys, how do we factorize this thing? Now we need to check, what if we put 1 in here? So this becomes minus 2 plus 5, which is 3. 3 plus 4, that's 7. 7 minus 3, that's 4. So it's not 0, out. Let's do minus 1. So this becomes minus 1 times minus 2, that's a 2. This becomes 7. 7 minus 4, that becomes 3. 3 minus 3 is 0. So yeah, this works. So if we put a minus 1, it means this one is an x plus 1. That is a factor. Now we need to find the quadratic factor. So you do this by trial and error of checking what values of x give us a 0. Once you find 1, write it as a factor. So we're going to do this by inspection now. So all we know is that we need this to come up. So this is going to have to be 2x squared. Right, so that we can get that. And then we look at the last one. If this is 1, this must be minus 3. Now to find the middle term, I often just look at this. This one is the easiest. but sometimes you can choose your battles. So all I want is to come up with a 4x. So I already have x, and x is going to be minus 3x. So if this is minus 3x, I need 7x to come up here. So this should be plus 7x. Right? Because now minus 3x plus 7x is going to give me that. So by inspection, it's done and dusted. Okay? Nice and easy. Now we can further factorize if we can, but if we can't, we just check the discriminant of the quadratic. But let's see, sometimes we often are able to. So this is minus 2x, this is x. Now I need 7, so I'm going to put minus 3 here, and then I'm going to put plus 1 here. So this is going to be 6x plus x, it gives me 7. So yeah, it's factorizable. So we can see therefore that x is minus 1, or x is going to be a half, or x is a 3. So this means this is minus 1, this is a half, that is a 3. So those are the intercepts. Nice and easy. Okay guys, so this is just as simple as it looks. So knowing how to factorize by inspection makes life a lot easier. But you may want to learn the synthetic division and long division. Again guys, there's a video on NPTs, which I think I did that, or even on paper 1, but let's just show you. First of all, we do trial and error, so this is key to it all. It's the common first step. So we just write x plus 1, and then we do long division. We write this minus 2x cubed plus 5x squared plus 4x minus 3. Now we ask ourselves, how many times does x go to minus 2x cubed? It goes minus 2x times, and then we say minus 2x times x is going to be minus 2x cubed. We say minus 2x times 1, it's going to be minus 2x. Now there's a negative there, so it changes this to be positive. So minus 2x plus, this gives us 0. 5 plus this, it gives us 7x. Wait, this is squared. Yo. Big mistake, né? So yeah. Now this is this. Then we drop this one. Plus 4x, and then we ask, how many times does x go to 7x squared? It goes 7x times 7 times that. It's going to be 7x squared. That times that is going to be 7x. Again, there's a negative hovering around, so this goes to 0. This is 4 minus 7. It's going to be minus 3x. We drop the minus 3 as it is, and then we ask, how many times does x go to minus 3x? It goes minus 3 times. Minus 3 times x is minus 3x. Minus 3 times plus 1 is minus 3. And then there's that negative doing its thing. So this goes to 0. This goes to 0. So when there is no remainder, the quotient is our quadratic factor that we are looking for. Okay. Great. So we know that the divisor multiplied by the quotient gives us the dividend. Okay, so that's long division in a nutshell. All right. Okay, so please guys, know how to do long division properly. This is very important. Now those of you who like the synthetic division, Now synthetic division is such that the equation is ax cubed plus bx squared plus cx plus d. It always has to be in standard form before we can do synthetic division, which is very easy, by the way, because all we do, we just do this like that, and then we write the coefficients as they are of our expression. So we've got minus 2, then we write plus 5, and then we write plus 4, and then we write minus 3, right? Right. And then of course, what did we substitute? But now this time we saw that we substituted minus 1, so we put the minus 1, not this factor now, like that. And then we let this one through, right? So this is minus 2. Then we say this times that, it gives us 2. Then 5 plus 2, that's 7. Right, and then we then say 7 times that is going to be minus 7. This one gives us minus 3. And then this minus 3 times minus 1 is going to be plus 3. And the last one gives us 0. And every time we come up with a 0, we know this is complete. So these become the coefficients. So it means our quadratic factor is going to be 2x squared plus 7x minus 3. Okay, this is much shorter than long division for sure. But you need to know that the equation needs to be accounted for in the standard format. Whichever term is missing, you put a 0 for it, because if the 0 is missing, the answer becomes incorrect. So you see, once you know long division, I think you are safer than all these shorthand techniques, especially when you don't understand how those techniques work. Anyway, guys, I've shown you all 3 techniques in a nutshell, so you should know and pick the one that you can handle. Right, so this factorization first is a mark. Okay, maybe getting this one and getting this factor is a mark. And then factorizing this one further is a mark. 3 marks. How many marks here? 4. Wow. I guess the marks are here, here, and here. So one of the factorizations is not recognized. Goodness. Okay, it looks like nope, it's not this one. So we can say the complete factorizations then. As for the rest, is up to you how you went about it, it seems. Okay, 9.2, we need to calculate the coordinates of B and E, the turning points. So we know that B and E are such that the first derivative is equal to 0. Which implies we differentiate here, we get minus 6x squared plus 10x plus 4 equal to 0. So we can divide throughout by minus 2. So we will get 3x squared minus 5x minus 2 equal to 0. So this implies we can factorize. So this is 3x, this is x, we want to get to 5. So what we can do, we can align this with the 2 and then the 1. Now this must be negative, this must be positive. So we know therefore that x is going to be minus 1/3, or x is 2. Now we need to say, then we know that f of minus 1/3 is what? And f of 2 is what? I will just take it to the calculator and just jot down the answer. Sometimes there's no point to show this very boring substitution. So this is minus 2 into minus 1/3. Again, guys, take your time here. It can get messy. It can get very messy if you are in a hurry a lot. So take your time, do it properly without trying to act all too smart and quick. I know time is an important factor, but accuracy is more important than time wasted thinking you're just saving it. You can't save time and achieve nothing, okay? Rather lose time and achieving everything, okay? Okay, let's start again. I don't trust this answer. It looks strange. So minus 2 into minus 1/3. This is cubed, okay? And we've got 5 plus into minus 1/3. This is squared. Plus 4 into minus 1/3. Minus 3. So I'm getting minus 100 over 27, okay? And then let's see when we put a 2 instead. So sometimes simplify your work, guys, by making sure the structure is proper, because I got an outrageous answer which made me believe that there's no way. Again, when you work with this long enough, you will even be able to predict when the answer is totally ridiculous. Okay, here I'm getting a 9. Now I can accept these values because I'm expecting a negative y value for b, where this is 1/3, and then I'm expecting a positive y value for e, where it's 2. So this is good. I can make a conclusion that therefore b is going to be minus 1 over 3 and minus 100 over 27. Okay, and E is essentially 2 and 9. Okay, remember guys, we were asked for coordinates, not x or what, both of them. So we need to see the ordered pair for each answer, even if it's not a mark per se, because we know that how many marks is this? 5. Okay, doing the differentiation is a mark, né? And equating it to 0 is also a mark, I suppose. And then we can just say, I don't like this question though. This and that, 4 marks already. And what about this one? So this should be 6 marks, man. Ay, yabona vele ngiphambanise lento. So it looks like we're not giving a mark for this guy. Damn it. Whatever, guys. But remember, you lose a mark if you don't show the ordered pair. It's a rule because the question said coordinates, meaning both x and y. Please do not find yourself not showing those two, okay? So the ordered pair is good, meaning we have to show it as such, although the marks may not necessarily be given there. Okay, 9.3 says we need, okay, for which values of x is the graph concave down? Now the concavity, we can say, well, what about here? Perhaps it changes there, the concavity. So what is this x value? Because we can say from here going this way, it's certainly concave down. So we just want the x value there so that we can take that x value and say we're going in this direction. Right, but now we have the x coordinates of the turning points. So we know that basically this is going to be x greater than the average of the turning points, which is minus 1 over 3 plus 2. As a whole, we divide this by 2 because this is the average. Okay, there's many ways of writing this, which implies that x must be greater than. Now we sort this out. This is 6 minus 1. This is 5 over 3. We then multiply with the reciprocal of this. And so we can say, therefore, our x must be greater than 5 over 6. Okay. Nice and easy. Now let's see, is 5 over 6 greater than a half? Should be though. Yeah, that's 0.8, so that's bigger than a half. So this is good. So we've got 5 over 6 there. And so that's how we do it. Of course, when it says for which values, it's more like determine. So at determination, we can show the steps or we can show the answer. But of course, for me, I would give a mark here for this average business. I would say this is a mark, and the overall sign that it should be greater than that and the final value. Someone may just say, I mean, if you write the answer only here, you would be dead, I suppose, because a 3-mark question, be very careful of not presenting the answer only, unless we have enough to do that, okay? So this is one way of doing this question. The other way would be to use the second derivative. Okay. Now the second derivative, we know that the second derivative for concavity must be less than 0 when something is concave down. This is for concave down. Okay. So this implies now we take the second derivative, which is that one, we differentiate it again. So we get minus 12x plus 10 is less than 0, which implies that minus 12x is less than minus 10. Therefore, we'll see that x, the sign changes when we divide by negative. So 10 over 12, 2 goes 5 times, goes 6 times. There it is. Again, nobody told us use the graph to do this, so one can resort to the algebraic way of doing it and sort it up, okay? So there's options here, guys. Not a big deal. Can use the formula for the turning point. We just want the x coordinate. So the x coordinate can be obtained from this graph by using x is equal to minus b over 2a. Can you see there's a lot of ways in which this can be arrived at, and whatever we get from there, we take it down here. Right, it comes down here. We then answer the question. So there's many ways, many avenues that a student can pursue, but make sure that you know your stuff, okay? Right, so let's do 9.4. So 9.4 says, for which values of x will x, now this is any x value, meaning all real values of x, multiplied by f prime of x. What is this? This is gradients of f. Okay, so now we're looking for any x value as a real value. So if we look at x, we can see that, well, for x, we can consider 0 and go in that direction. Those are negative x values. Or we can consider 0 and all the positive x values, okay? So that's what we need to consider for these x values, okay? This is negative. This is positive x values. Easy, and that's 0. Now, gradients, on the other hand, we need to think about tangents to this graph. Before this turning point, the tangents are negative, so this is a negative gradient. At the turning point, it's a horizontal line, so this is 0. Past this, this is positive, and also up there. And when we get here, it's 0 again. And past that, tangent lines register positive gradients. So all we need to know is just the slopes by just using tangent lines, because we don't need to do the algebraic calculation. It will help, although we can still do it. Now, what do we want? We want to have this greater than 0. Can you see 0 is not included? So for this to be greater than 0, it means we need to multiply a negative and a positive, right? So we can clearly see that we need to divide this graph into segments, because we know here that we have a third, right? Minus a third. And we know that at this one, we had 2. So we need to consider those, okay? Now, there's a half in there. Okay, maybe let's showcase these ones properly. There's a half in there as the x-intercept. The point of inflection doesn't really matter, so we've got a 3. So how are we going to plan this? Now we need to look at these few regions. Okay, so we need to consider those shaded regions. Now let's have a look here. We've got a negative on this first region. We've got a negative x x value multiplied by a negative gradient. So that gives us a positive answer. So this region is good. We get to the pink one, or whatever that color is. Now we've got from 0 to that. So when x is 0, whatever we multiply it by, it's going to give us 0, so we cannot take that. In between, and again, we know the gradient at minus a third for the function f, that is 0. So again, we cannot take the zeros. So in between, we've got a positive gradient and a negative x value. So this is not allowed. Anyway, the limits and in between, not allowed. And then we look at this yellow section. We have a positive gradient and a positive x coordinate. So this, or x value for that matter, that is going to give us a positive answer, greater than 0. Then at the limit, we're not going to take it because we don't want 0. Here we got a negative and a positive x value. So that gives us a value less than 0. So this is not allowed. So just write those regions that are allowed. So x must be less than minus a third. Or x, now this one is a region. So we know that x is going to have to be less than 2, but greater than 0. That's it. So, yeah, this question is heavy, guys. 1 mark, 2 marks for that. We get our 3 marks nicely. All right, so last question here, 9.5 says, for which values of k will this expression, can you see this is similar to what we have in terms of f? But what you will notice is that the 2x squared was negative, now it's positive. The 5 was positive, it's now negative. The 4 is positive, now it's negative. The 3 was negative, now it's positive. So what happened here? So basically we've got minus f of x. See, this is a vertical reflection of our graph. Okay? So this is a vertically reflected graph of f. So meaning x coordinates remain, but the y coordinates change. So let's do it. So this goes somewhere up there. Right, the y-intercept goes somewhere here. And then the x stays. That one comes down here somewhere. And then that one stays. And this one stays. So the graph looks stuff like this. My lord, my lord, my lord. So it's gonna look stuff like that. And we can continue like so. Of course, it's not gonna be as accurate as I want it, but it's gonna go somewhere. Hi man, so what's a straight line kalog now, kini? Yeah, okay, bow. Okay, for non-kaila masiya again so this one is gonna be doing stuff like this. Now it's a knife non-kaila gagbi. Okay, that's a little bit better, but not exactly the way I want it. Okay, so this is more like it, guys. So sometimes it's not going to be as accurate as I want. So the graph changes shape, basically. Now it's going to be equal to the constant k. So k is a straight line or any horizontal line. So we can make this nice purple. Okay, maybe we've used it. Is there any color we can choose? I'm running out of colors. Maybe let's choose this one. So by the way, if we draw this at the level of the turning point, this is what we get. Okay, not exactly the way I want it. Yeah, more like it. Of course, this would mean the graph here. So this graph continues down, right? So what we're going to notice is that we'll have 2 intercepts, that point and that point. But now we want 3 roots instead, not just 2. Because this is the line. This is the line y equals k. But if we do it in between, right? If we do it in between, we will have the line y equals k. But we see that we've got 1, 2, 3 intercepts. And this continues until we get to the turning point. Of course, guys, this didn't come out so well, but we'll make it work. Again, this is the line y equals k. But now what we notice, we just get 1 intercept there and 1 intercept there. So there's just 2. And beyond, there will just be 1 intercept. And below this 1 intercept. So this already tells us that this guy is not allowed. And that one is not allowed. And this one is allowed. So this means this is going to be basically between this maximum value in the original. No. It's going to be between this maximum value and this minimum value for the y. Okay. So we know that k is going to be less than the maximum. So what would be the maximum? Remember, this was negative 100 over 27. So when we multiply that by negative, it becomes positive. So this is going to be 100 over 27, but greater than this value right here. Now remember, that was 2 and 9, so then the y coordinate is going to be minus 9. So I guess the key here is essentially to get those done. Okay, so this is it, guys. So we get our marks here. I guess first is the inequalities, and the last mark is just the sign changes, I suppose. Okay, here there's a plus sign. I guess maybe that's the way it works, because honestly speaking, this is what it's gonna be. But sometimes when I see something like this, I know there's more I need to say. So sometimes, to avoid being silly, of course you can get full marks for the answer. It's not really so bad, but I feel like there's something that we need to say first. We then know that the maximum turning point is going to be, now this is going to be minus a third, because this is going to happen the reverse one. So this is going to be 100 over 27. And the minimum turning point perhaps maybe we can just say turning points instead of stating which one is which. It's not really a big deal. We can say here the turning points are minus a third, the 100 over 27, and 2 and minus 9, because the x values remain, because that's a vertical reflection. So this is a vertical reflection of f. Okay, so we can say therefore k must be less than 100 over 27, but greater than minus 9. Now this is good, and that gives us the extra mark, because I do feel 3 marks we need to say a bit more than just the sign changes, I suppose, or I believe. Again, guys, this is 2 higher grade questions that are not so easy, but again, you can do the algebraic technique using the table method or using the graphical method, but the fact of the matter is, get it right, students. Do not fluff this. Okay, so guys, this was a rather nice 18 marks. As you can see, these are not questions you can rush through to solve. You need some thought, some working out. As you can see, at some point we are given a reflection of that graph. So we need to appreciate reflections and be able to then answer questions adequately. All right, nice question there. So let's do the last question and end this pain. Can I really squeeze it in here? Obviously, guys, for you, answer this on a new page, but I think I can squeeze it here. It doesn't look too long. Looking at this mark allocation, it's not really that big. Okay. Now question 10, we're given f of x is going to be px cubed, okay, plus qx squared plus rx. But what is important, we can clearly see that the y-intercept here is the origin. And this is also going to be another x-intercept, because we just have an rx, we don't have the constant. So this is the first thing we're going to get, okay? And then we're told p is greater than 0. That's the language we want to hear. This would have been the a value. So it tells us that on the Cartesian plane, our graph is doing stuff like this. Okay, so the shape is already outlined here. Great. All right, so this is the shape that we're given, and then P and Q are element of real numbers. Cool. And the turning points of F are given by P, which is A is to F of A, and Q, which is B and F of B, where A is greater than B. So now if A is greater than B, it means this turning point is A, where that turning point is B. Okay? That's the essence of this whole shenanigan. Okay, very important stuff. So this means this is going to be basically Q. And this means this is going to be P. All right, very important. Can you see, guys, what we're doing? You can see it. You can see it. I like these hypothetical questions because these ones are higher grade questions purely. They will give you goosebumps. Calculus is taught in the second semester, so I don't know why they're already asking higher grade questions, you know. These higher grade questions should be coming for the trials, guys. You punish kids. But anyway, differential calculus is easy. Okay. In fact, the entire calculus is easy in my opinion. Even if it's one that you do at higher levels, you still apply the same principles that you do at lower levels. And of course, some few extra techniques you will learn depending on the complexity of the topic and where it applies. But in fact, calculus is easy, man. I don't think maths is that difficult once you get to calculus. But you just have to understand the different aspects of it. Anyway, which points P, Q represents the minimum and the maximum? The maximum is the one with the bigger y value. The minimum is the one with the lesser y value. So we answer these questions. So 10.1. We know that P is the minimum. And Q is the maximum turning point. Okay, nice and easy because we see the shape. We needed to understand the shape to know this. Nice, 2 marks. 10.2 says, is f of x increasing or decreasing when x is greater than a? So we just draw a tangent. When x is greater than a, we see a positive gradient, so it is increasing. Right. Again, 2 marks. 10.3, write down the coordinates of the y-intercept of f prime. Now when we differentiate f, we end up with basically 3px squared plus 2qx plus r, and this is the one. So it's going to be 0 and whatever the r value is. Okay. Again, guys, 2 marks. Wow. Nice and easy. 10.4, write down, giving a reason, the value of f prime of x if x is equal to b. So we know there that the gradient, because f prime is the gradient, so the gradient at the turning point is 0. It's a horizontal line, so it's a 0 gradient. So what is that? It says write down the value. So fine, we know that f prime of b is certainly going to be 0. Why? Because f of b is a stationary point. or we can say it's a turning point. Yabo. What am I saying? Okay, because let's say B is 2, f of B is a stationary point. Kanti tenzo bhala kahle kangaka ekugqibeleni sonhlanyela wena Scotlandina. Okay, so guys, at a stationary point, we know that the first derivative of that very x coordinate is going to give us 0, right? Right, so we get a mark for this and stating that this is a stationary point. Nice and easy. Okay guys, although this looked scary, but it's actually basic. It's a very mild higher grade question, I suppose. So 10.5 says, write down the coordinates. Again, we're writing down answer only of the x-intercept of this equation. Now in terms of A and B. So what is this, guys? This is the second derivative of x. Second derivative of f. Now we know that the x, so basically we know that the x coordinate of the x-intercept, or let's just say the x-intercept, is going to be the average of these two turning points. So this means we can say here, this point is basically going to be the average. So it's going to be A plus B over 2 and 0, because it's an x-intercept of that second derivative function. So this is good. See guys, basic questions that looked almost scary. So this is some cheap 10 marks. I actually want to say, is it really a higher grade question? Maybe a standard grade question that fits both higher grade and standard grade. So yeah, it's both SG and HG here. Yeah, it's not exactly standard, it's also not exactly higher grade. So if you know the things, you know the things. Alright guys, so this is the work we would take for these 150 marks, provided we have not made any silly mistakes during the analysis. But of course, I tried not to overly indulge, as I often do, to save a bit of time. This is holiday season. Sometimes you get bored. Instead of watching a movie, watch this review so that you get better and better at this. And you start killing it just right. As you can see, there's a whole lot of stuff that we've had to do to then understand how to work out these problems. But this was a nice question paper, guys. Keyword is study. Study. And studying is not just reading, doing some basic, exercises and then stopping. No. You look and explore the questions. You answer it at first, you check if your answers are correct, and you start exploring options and how you would tweak this question to say something else, because that's what we call studying. When you explore what you are dealing with, instead of wasting time doing structured questions which are already asked, which means they're not going to be asked again, or the likelihood that they're coming back is not so possible. But the tweaking of those questions that you can perform is more likely to come, because the same question can be brought back, twisted, or shifted about. You can get a copy of this question paper at essayexampapers.co.za, or check the description. I will attach this question paper to this memorandum so that you can peruse it for those who wrote this paper as a form of remedial work, and you are getting ready before you actually do this in class. So you'll be able to participate and perhaps, follow your teacher's thought process than you would if at all you had no prior, idea being shared about these questions. Otherwise, guys, well, good luck. Please don't just relax too much. Rest, yes, but when you get bored, instead of watching a movie, please watch these videos. There's plenty in the channel. Watch as many as you can so that as you come closer to your trial exams and the finals, you're not going to be overwhelmed by the volumes of videos in the channel, because you end up not knowing which one to watch. Okay, but I can tell you, if you want to watch any important videos just before the exams, watch the long videos where I do full papers, because there you will then be able to revise most of the stuff, because I do a comprehensive analysis, of course pointing out those key elements in the topics that you are taught in class. One by one, I put them all together. So these reviews, guys, I promise you they can help you, even if you are to not know what to do. But just watching these comprehensive long videos, you will be good to go, because you will then see that there's very little for you to go back and double check, because some of the things I highlight as I go along. I don't just solve by reproducing what is already on the memo. I try to show you options at least. I hope that helps. Although it may look as a time wastage, but it's actually time well spent, because after that, if you really pay maximal attention and you practice along as well, you will see that you can succeed, even if you did this as some crash course before the exam. But I would advise you to not allow it to get to that point, because it's more likely to overwhelm you. Now that you have time, go through those videos, making sure, because trust me, from now on, all the mathematics you need is going to be examined in the trials. So you might as well start watching those full question papers like this and many others, so that you can see what is necessary to then go and kill those trials, so that you know clearly that come finals, you are already cruising. Eliminate maths and physics as the problems, so that you can start focusing on those technical aspects of the other subjects, to then bring up a very good average that is effectively a distinction. Don't worry about the 100%. It doesn't mean anything. It doesn't place you at any opportunity than a distinction does. Okay. Otherwise, guys, have a good one. I'll see you tomorrow at 7. We should resume our classes so that we can work slowly towards all these topics of paper. Term 3. So what I want us to do in this meantime, I want us to actually spend this few days of this week revising work from from term 2, using these provincial papers. Please, if you can find them, do share them in the group, because I'm not able to access all. I'd rather you just try and see if you cannot find all these provinces term 2 papers, so that we can sit on each every day and then do as many questions as we can. Of course, we will skip some common and easy questions and focus on these higher order questions, just to try and make the revision more interesting, at the same time informative. Then by the second week, as we near its end, we should be done with all of these papers. Then we should be starting introducing the topics for term 2 nicely. I'm not going to overwhelm you guys. We'll just spend an hour or an hour 30 minutes, maximum 2 hours, so that by the time you study this in class, it's already a form of revision, so that you can master those homeworks, those projects that you may have to do, investigations, whatever you call them, assignments. Then we can start intensifying the preparations for the trials. Once everything is done, So that guys, you are ready well in time, because the 2 weeks before the trials you should already be doing revision by doing as many exam question papers that you can find on different topics, and of course asking questions during our classes and revision sessions. I can tell you, you're guaranteed a distinction if you can work alongside me. Please guys, ask your parents for very good internet connections. Telkom has very good packages, guys. Just ask your parents to purchase some good. I mean, the unlimited now from Telkom is around 500 some change, and make sure they buy it, and during your classes nobody else uses the internet, so that it becomes strong, so that you don't miss out on the class. A lot of you get kicked out by your internet connection, because while you are studying, others are busy browsing through social media, which is ridiculous. During that hour or two, there shouldn't be anyone using that, so that the connection is stronger for you. Okay? Because I mean, guys, your parents can afford these things. Instead of them buying you a pair of shoes that cost 2,000 rands, they can just buy you an internet for 4 months. And you hardly need that for that much, you know, because all you do, you just get that for just 4 months if you can. Then we work, and guess what, you will be good to go. Anyway, goodbye guys. I'll talk until Jesus comes and goes again, and he will still come back, find me talking. I'll even talk in my grave, I guess. Yikes, that's strange and very scary. Anyway, ciao.